Thank you everyone for joining us today. We're here to discuss cybersecurity issues related to ransomware, IoT vulnerability, and quantum computing. We'll start our webinar with a brief introduction to our speaker, and then I'll hand over the stage to Andrey Iaremenko. And at the end, we'll also do a short Q&A to wrap everything up. So I'm joined here now by Andrey Iaremenko. Hello, Andrey.
Yeah, hi Stephanie, hi everyone. Thank you for joining us today.
Andrey, thank you for joining us as well. You can turn on your video if you'd like, so we can see your beautiful face. Hello.
Hi.
Andrey has a vast technological background in software and hardware development. He specializes in the architecture of complex software and hardware systems and the integration of the two, while minimizing and utilizing technology in real time. During his 13 years of experience service in the IDF's 8200 elite unit, Andrey gained rich experience in managing RF design and manufacturing, boards, embedded programming, FPGA design, hardware design, and implementation. Give a warm welcome to Andrey.
Hi everyone, thank you for the intro. So I've been working in cyber domain for 15 years now, starting with the IDF, the Israeli army, then a few years in the defense industry, and recently as a CTO in a hub security company. And during my career, I've created a variety of solutions for many different kinds of problems and challenges, starting as a developer and then as a project manager and system architect. And I do love extreme tech and complex things, complex issues, and also bringing abstract ideas into real tangible things that actually help people to solve their problems.
Oh, great. We're very happy to have you with us. So I want to start with discussion, starting off with the topic of ransomware. As you know, today the world has become increasingly aware of the threat of cyber attacks and data breaches, but not all organizations really have a grasp at how to defend themselves against them. System breaches, big and small, have more than doubled in the past 5 years, and the attacks have grown in both sophistication and complexity. Based on a recent article that you wrote on ransomware, I was wondering if you could talk a bit about the current state of ransomware and which industries we see are being targeted, especially now in the times of Corona.
So actually, the ransomware is growing exponentially in these days, in the past few months, since the Corona broke all over the world. Just like in any time of crisis and when people are in indecision and looking for solutions, looking for help. And recently we're seeing that the main industry that is being targeted is the healthcare industry, when for the first time in many years, it needs to provide remote services and remote help for the patients, where there is no possible physical access to the hospitals. And in this way, many healthcare systems, hospital infrastructure is being much more open to attacks, and backdoors and vulnerabilities are much more easy to exploit when everybody is working from home, both doctors and patients.
Yeah, I couldn't agree more. You know, ransomware has cost businesses more than $75 billion a year in damages, according to Datto. And the ransomware attacks remain one of the most common forms of cyber attack. By the end of 2016, around 12% of global enterprise detections were ransomware. And by the end of 2017, 35% of small to medium-sized businesses experienced a ransomware attack of some kind. What do you recommend companies can do to protect themselves against ransomware attacks in the future, as well as in the times of COVID?
So that's a great question, and I think in general, the most important and useful form of protection is education, so that the companies pass the knowledge about the ransomware attacks, about how to manage the emails and the unknown sources of data that are coming into the employees' inboxes and into and being delivered to them electronically. And by continuously educating the employers on the dangers of the ransomware, bring the actual examples, real life examples that can touch people personally from the real life, then it will keep, think about like 80% of the ransomware away from the company, as it is basically a human engineering attack where hackers try to get people to open a document, to open a video, to click on the link. And when people are aware of the dangers, are aware of basic digital hygiene, and keep it in their day-to-day business, it keeps most of the hackers away.
Great, thank you. And according to a Kaspersky Labs report, cybersecurity statistics show ransomware attacks were launched from within more than 190 countries, with financial services the second most targeted industry after healthcare. What do you think makes banks and other fintech companies such a big target for cyber attacks? And as a follow-up to that is, what can these organizations do to get the target off their back?
So the basic reason is that banks and financial industry companies are dealing with the actual money, real money, and it does not have identity, it does not have address, and it is immediate payback on the hackers' efforts. So the moment hackers steal the money from a bank, they can transfer it and use it and make the profit, as opposed to, for example, personal information, where they need to make an additional effort to sell this information to third parties, and they spend more time on it before getting the profit. So that's the basic, I think the basic reason that it's much easier to target banks than other types of companies. And also, banks are the monetary infrastructure of the society, of the world. So everybody keeps their money in a bank, almost. And getting inside the big bank or central bank, for example, as a Bangladesh bank example in 2016, enables the hackers to, in one effort, to steal tens or hundreds of millions of dollars in one go, and make a very large profit for their efforts. So that's on the first question. On the second, so yes, the financial institutions, they will always be a target, because it's very easy to steal and easy to make a profit. And so for the long run, the protection, first of all, it's the same one as for any other kind of organization, as I mentioned previously, doing continuous education for the employers, and bringing the actual examples that are happening in banks all over the world. And there are many such examples of stealing money from banks, from remote hacking attacks. And the second one, banks, they have an advantage as the heart of the bank, the information and the data that controls the money, the keys that are controlling the money, are usually very small part of the whole banking infrastructure. So instead of protecting, or in addition to protecting the whole bank network with generic firewalls and software-based protection, which hackers can overcome very, very quickly today and relatively easily, the bank can and should protect the money controlling information, the identity management access to the money movement itself. And the best protection in this way, in this case, is using a separate physical infrastructure, a separate physical hardware servers to keep the most critical information. And to protect this most critical information and this specific infrastructure with separate dedicated firewalls, separate dedicated unique tailored protection. So the hackers that will get into the bank network, and they will get inside, doesn't matter what's the firewall on the internet access, they still will not be able to use the money, to steal the money from the bank. So that's a two-step protection, like any other organization, and also to identify the critical information and protect it with best effort and tailor the means of protection to prevent hackers from stealing the money itself.
Right, it's very true. But while majority of exploitation stem from software vulnerabilities, we also know that hackers can just as easily begin from vulnerable pieces of hardware. And anything from an employee device to a router connected to an unsecured network can put an entire organization's digital infrastructure at risk. What would you say are the IoT threats that Cisos and organizational leaders should be considering when planning their cyber defense strategies, not just from software endpoint, but from a hardware endpoint?
So first of all, it begins with the awareness of the organization and all of the leaders of the organization, from the team leader and all the way up to CEO, about what sensors and participants are in the organizational network. It can be in the same building, it can be all over the world from global organizations. And it's not enough to think about the computers, the servers, the network routers. We also should think about the small devices. It can be as simple as a light control sensor, or a climate control sensor that is connected to the Wi-Fi inside the organization network, and has an open interface to the outside world for collecting data. But the security of this sensor, because of the extremely low cost requirements, is essentially non-existent. And for the hacker, it is much easier to go for and search for this kind of sensors, for the security cameras that are connected to the internet, and other types of low-tech small devices, then to go and break the enterprise grade organization firewalls on the cloud, on premises. And once the hacker is inside the network, it doesn't matter how he got inside. Then he can do whatever he wants. And these small sensors are exactly this most easy way to get into the organization network. And they are often overlooked by the security people, or the IT security teams, and enable hackers to get into the organizational networks is much more easily than through the normal Ethernet interfaces.
Interesting. I remember that we promised in the last discussion that we had that we would cover the topic of quantum computing. And I think this might be a good time to transition into it. And I'll start by asking you about the recently published story of Google's quantum computing project, which was dubbed Sycamore, that has now claimed quantum supremacy over the most powerful supercomputers in the world by solving a problem considered virtually impossible for normal machines. I wanted to ask you, why is quantum computing being discussed so often today, and what's its relevance and importance?
Wow. So yeah, it's a great topic. It's very, very interesting and exciting topic to talk about. And the main reason is that everybody is excited about the quantum computing, and every news that tell about, okay, we have conquered a new step and we have a bigger, faster quantum computer is because potentially when we have a real general purpose quantum computer, it will be a huge leap for humanity in our capabilities of predicting the future, first of all. For example, in simulating the weather patterns all over the world and doing it in real time and in much higher precision. So that's one benefit. And it will enable us to solve extremely complex problems and simulations and real life scenarios on many orders of magnitude faster than using current supercomputers that we have today. So the potential here is huge for the humanity. And but then there is a catch. The quantum computer is as a concept is relatively understood and formalized, but the implementation is very, very complicated or complex even, and it goes very, very slowly, slow step by little step, with many big organizations developing this quantum computing.
Yeah, when do you think and when do you believe that we will be able to reap the benefits of quantum computing technology as it relates to real life applications?
So it's now coming back to the news. So the news, for example, about the Sycamore project. Okay, they told it is we have a new fast quantum computer that will break the world. But in reality, the quantum computing today is really in the very beginning, nascent stages of development. And what we have today is small chips with a few tens of qubits usually, and they can do today very specific types of applications, very specific types of computations, which has almost no relevance to the real world problems. So today it's more for the academia and labs to do very, very specific focused research tasks, to do them faster than normal computers. And it's also extremely expensive and physically large. So a single small chip that does the quantum computing requires today almost a room-sized equipment around it for cooling and proper access to the chip itself. It's very hard to program, and so it probably will take quite a few years until we have strong enough or enough performance from the quantum computer device. And also when we can actually program this quantum computer device with real life problems, things that regular researchers and programmers can just write programs that simulate real life problems and get solutions that benefit us in day-to-day life. So to summarize, it will probably be somewhere between 5 and 20 years, depending on the technology breakthroughs that are being made. And the positive side is that very big companies like Google, IBM, governments are working very actively on quantum computing and investing lots of money in research and development to move as fast as possible to general purpose quantum computer. So that's the positive news. And it looks like it will happen eventually.
Very interesting. You also mentioned right now that quantum computing will break many of the privacy protections we have today. What can we do to protect ourselves and our data from quantum technology in the future?
So it is, yeah, it's general knowledge that quantum computing can actually break all the existing standard encryptions like RSA and elliptic curve encryptions and signatures. This is a big problem that organizations and governments are thinking about and working also on the algorithms that are called quantum resistant algorithms, so that even when quantum computer becomes a reality and they can run encryption breaking algorithms, still the data and the privacy of the people and the secrets of the organizations and the governments will be secure, even in the post-quantum era that we're going to reach eventually. And so to protect ourselves, it's two answers. One, as a private individuals, what we can do is to use the new algorithms that are being developed, and that's only for technical users. So the programmers and the experts that understand what the algorithm are and can develop their own software, and in this way can be sure that their secrets will not be exposed the moment quantum computing goes general purpose. As organizations, this is something that we need to think about today, and to prepare, and to prepare the infrastructure to support the novel quantum resistant cryptographic algorithms that exist now, and new ones are being developed. So when in several years we have we're going to break all the existing encryptions, the current data will still be safe. So it's not only what's going to happen in the future, but it's also what's happening now. So when we today use standard algorithm to encrypt the data, and 10 years from now, somebody can take this encrypted data and break it very easily with a quantum computer, then it's also a problem. So to be really protected, we need to start defending today. So the data will be safe in the future when the quantum computer comes online. And the problem is that many existing infrastructures do not support these quantum algorithms that are very new, and organizations usually need to change to upgrade the software, and in many cases the hardware, to be able to run these algorithms accelerated and on huge scale. A process which is slow and happening in slow steps, but it will happen eventually.
It's really fascinating. I have a follow-up question to that, which is, which industries do you really think are at the highest risk for impact from quantum computing attacks?
Wow, all of them. The simple answer. A more detailed answer is the hackers will go, hackers, the governments, whoever owns the quantum computer. First of all, the government secrets are the highest risk. All the secret communications and data from the governments have huge value for other governments in the world,
right.
And that's the highest risk from quantum computing devices breaking the encryption. On the second layer, for the businesses and enterprises, every company has a secret IP, has a secret software or designs, things that they don't want their competitors to know. For example, Coca-Cola secret recipe, if it's encrypted with the current standard algorithms on the servers, in the future, the encryption can be broken and then anyone can make Coca-Cola. So it can kill entire organizations when somebody gets their unique secrets, unique knowledge, even if it was developed today or 1 year ago or 5 years ago. So the risk is very big because everything is now online. Our current conversation over the webinar is online, and it's being stored and encrypted somewhere, and we don't really control where the data goes and where to store it on the cloud. So the risk is real and very high for any organization, any enterprise, any business that exists today or will be in the future.
Yeah, I would agree. I wanted to ask you one more quick question about quantum computing, which is, what would be the most common use case for quantum computing? For example, which applications would make sense to run on a quantum computer? We mentioned now that there's a really broad use case for it, within government or within existing institutional infrastructures. Can you give us another example where you think quantum computing will really have a big impact on the way the industry functions?
Yeah, that's a great question. So until now, I've been focused on negative things, breaking the encryption and destroying companies. Quantum computing will have many benefits for the society, and one of the largest benefactors from the quantum computing will be simulation domain, like simulating weather patterns, simulating physical phenomena, developing new cures for coronavirus, for example, or creating new drugs without testing them on human beings, on animals, and doing it much faster. So understanding the universe, which is very important for us as human beings to understand what happens inside the sun and what happens inside around the black hole or other big phenomena that also impact us on Earth indirectly. So everything that requires a huge high volume simulation on the atom level, on the molecule level, in biology, in chemistry, in physics, in astronomy, can be done much faster with quantum computing than with the current standard supercomputers that we have today. And just to add, another positive impact, when you can do computation faster, it's also uses less electricity. So all the huge data centers that we have today, we can save on natural resources, and we can save on the pollution of our planet. So the impact of the quantum computing is much larger than just compute. It has benefits for many areas of our life.
It's really interesting. Okay, well, thank you, Andrey. This was really all very super fascinating topics, and I'm so glad that we got the time to cover all of them today. Well, all of them require much deeper discussion. We're very grateful that you could take the time to flesh them out for us. Thank you very much. Now I'd like to take the opportunity to open the floor to our attendees. Anyone who might have a question, feel free to drop it in the Q&A section below or in the chat section. That's okay as well. And I'm going to share them aloud. Right, so we have one question here from one of our attendees. What is the meaning of quantum proof in terms of cybersecurity?
So essentially the cybersecurity, as I mentioned before, it's depends on the inability of the attacker to compute the solution to very complex mathematical functions. So to use the cryptographic algorithms, it is very easy. To break them, to break the math, will take thousands of years on using all the available capability of current supercomputers. So with quantum principle, when quantum computer can see all the possibilities at the same time, to keep it simple, then what takes thousands of years on a regular computer can take seconds or minutes on the quantum computer. So the impact on the cybersecurity is huge, because that's one of the main advantages of quantum computing, to solve very complex, very large mathematical problems, which security is based upon today.
Great, thank you, Andrey. We have one more question here in our Q&A. Well, this is a difficult question, but how would the math work if there are lots of unknowns on how quantum computing math works? Is it a question that you can answer within the next 3 minutes?
I try to make it short. So the math equations are the same, but the main difference is how to present this math in the terms that quantum computer understands. So it's very different, let's say, very different language and presentation of problems to quantum computer to solve, because of very different unique architecture that it is. And on the basic level, the quantum computer can handle math with the math equations of math problems with lots of unknowns, and can see these variables at the same time, and many different values that these variables can take at the same time. So this is the main strength of the quantum computer. And it depends a lot on the number of qubits or computational elements inside the quantum computer chip. So today we have chips with between 10 and 50 or 60 qubits. So it's very, very small quantum computing devices. So to make it into real life problems, we need to go to hundreds of thousands or millions of qubits to do real life computations.
Wow, very well done. And under 2 minutes. So with that, if anyone doesn't have any more Q&A, I want to thank everyone for joining us today, and thank you to our speaker, Andrey Iaremenko. Yes, thank you, Andrey.
Thank you, Stanley.
Of course, happy to chat with you and happy to discuss really interesting topics together. We hope that you're all staying safe and healthy at home, and we look forward to hosting many more discussions like these in the future. You're welcome to stay updated on our upcoming webinars via Hub Security's LinkedIn and Twitter page at Hub Security. And you can also check out Hub's weekly digest on Medium for the latest stories coming out of the blockchain and cryptosphere. So thank you everyone for joining, and I wish you all a wonderful evening